girls, your attention please. We have some special guests today from the University of Minnesota. These are students in the engineering and the physics and the math and the computer science department. Did I miss anything? Chemistry. Chemistry, all fabulous sciences. So anyway, they're giving you a preview of if you continue doing well in school and keeping your passion for science, you can be involved in some cool science stuff like this. So.
Okay, cool. So I guess we'll start with this experiment. Yes, this is fire. This is called a Rubens tube. It was invented by Heinrich Rubens in 1905. And basically how it works is on one end of the tube down here, we're pumping in propane gas. So that's a flammable gas. We're filling up the tube with propane. And then it comes out the holes on the top. And so we lit it, so there's a bunch of little flames. And that works exactly like a grill. On the other end of the tube, we put a speaker. So we can play music and sounds into the tube. I'll show you quick tone so you can see how that works.
Which one is it? Oh gosh. Oh.
Okay, so do you guys see that wave pattern? What's happening is that sound waves are basically vibrations in the air. And so when we play a sound into the tube, it creates areas of high and low pressure. So when there's higher pressure, more propane comes out and there's a taller flame. And when there's low pressure, less propane comes out and there's a smaller flame. And that's why you see the wave pattern. So we can also play different frequencies.
Think about our sound playground out there, how you can make different sounds.
Oh my god.
So you guys see how you get more humps when you play a higher tone? Yeah, do you have a question?
Does it go like really, really high?
Yeah, well, when it gets higher, the humps get smaller and they're harder to see. So there's like a certain range in the middle where you can see them really clearly. I can play that for you guys again.
Do that first one.
So you see, you got 2 humps and then 3, and then you'll see 4. Yep. And then the other cool thing, since we know it reacts to sound, we could play music into the tube, and the flames will dance to the music. Are there any questions on what's going on here? No? What's that? Oh. Because you guys are so smart, right?
We just like watching now, like just watching.
Yeah, I think they're ready. Yeah, let's see.
Why is the wood on the outside if there's fire?
What?
Why is there wood on the outside if there's fire?
The wood protects the flames from wind, because wind will mess up the effect. And since it's not going to catch the wood on fire or anything because it's so far away. Yeah, what's your question?
Before you put on the music, why was it going sideways?
Oh, why were the waves traveling sideways? Well, what was happening was we were increasing the frequency, which means we were increasing the pitch. So there's going to be basically different wavelengths. So you know how a wave goes up and down like this? Basically it's going to get longer and longer. So it starts off really long and then it gets shorter. So we're basically increasing the number of pumps. frequency, frequency is basically, like, you can think of it as how high the sound is going to be. So like a higher frequency would be a higher pitch.
So frequency is something, it's like the amount of time something happens in an amount of time. So like, if I snap my fingers in 2 seconds, that's the frequency. So for this, it would be like, there's a certain amount of waves that happen in a second, and that's how fast it's moving. That's the way you can think of it.
And then for sound waves, the frequency relates to the pitch. Yeah, let's do
Sure.
the next experiment.
Okay, this next experiment is a pretty awesome experiment. Personally, I'm pretty sure it's my favorite of the ones we're going to be doing today. So, what happens is in here we have methanol and boric acid. And so, methanol is kind of like the gasoline you put in a car. And so, when you light it on fire, it burns. But then, but it burns fairly clear, so you can't really see it that well. So we put some boric acid in here to make methyl borate, which burns with a nice color. It has a wavelength, sort of like they were talking about how the higher the frequency is, the shorter each wave gets. That's the wavelength. So in this case, the wavelength is about 530 nanometers. So do you guys know how big a nanometer is?
How about a centimeter? How big is a centimeter? Show us. How about a millimeter? How big is a millimeter? One-tenth of that? So what's a nano?
A nanometer is about a millionth of a millimeter.
So think of the teeniest thing you measure, which is a millimeter, 1,000,000 times smaller.
Yeah, so that's pretty small, right? And so that's the scale that the wavelengths of light are on. Because did you guys know that light is sort of a wave too?
Yeah.
Yeah, so that's the sort of scale the wavelengths of light are on. So, anyway, so what I'm going to do is, I'm going to take this nice little blowtorch of science here. First, I got to make sure to put the goggles on for safety purposes, of course.
Those are swimming goggles.
No, they're not.
No,
They're
like,
safety goggles.
so,
Fire.
okay. So we have our blowtorch here, and what do you guys think it's gonna? What color do you guys think it's gonna burn? Yeah?
Maybe red? So that
Red?
you can see it through the blue too.
Maybe. Yeah. What color do you think it's gonna be?
Maybe blue.
Blue? Yeah?
Green. Purple.
Yep.
Yellow.
Yellow?
Green.
Green. Okay. How many of you guys think it's gonna be, say, green? How many of you think it's gonna be blue? Purple?
What's in the bottom?
Red?
They're all different. You can't focus.
Well,
Like the same.
we'll see what color it's gonna be. Was that pretty cool? Yeah, so it was green, but who of you guys said it was gonna be green? Yeah, good job. You were right.
What was the gas in there?
Methyl borate.
Methyl borate. So you know how fireworks are different colors?
Yeah.
Fire mixed with different chemicals makes different colors.
And then because of that, we're going to need to pump it out in order to do it again, because what happened in there is actually called deflagration. It's kind of like burning. So what it means is that we started the flame right up here. Oh, it's still warm a little bit from that. And so then the flame just kind of went down and down. And as it went down, it kept lighting the other gases in there on fire. And then they burned up. And then just kept burning up. And then that made the really hot flame that you guys saw right up here. Cool. So then, but because of that, when you burn something, it produces carbon dioxide. And so now this tube is, filled with carbon dioxide. So we're going to need to pump that out of there.
Is it carbon monoxide battery?
Monoxide, not dioxide.
Yep. Carbon dioxide's in the air all around us.
That's what trees like to breathe.
Those
Carbon
blue
dioxide.
tins.
What comes out of your lungs?